So first thing, if I'm talking about matrices, they're equal if and only if they have the same number of rows and columns. Okay, and every corresponding entry in the first has to be the same as the entry in the second. This subscript Aij just means in matrix A, row I, column J. So it's just essentially saying they are only equal if they are identical. So this were the first matrix, row 1, column 1 is a 1. So the other matrix to be equal, row 1, column 1 has to be a 1. Row 2, column 1 is a 3. Row 1, column 2 is a 2, and so forth. So exactly what you would have expected if I hadn't told you. They're equal if all the corresponding entries are the same. Some special matrices that we might have. A square matrix has the same number of rows and columns. So this would be a square matrix because it's a 2 by 2, 2 rows, 2 columns. So that's square. 3 rows, 3 columns, so forth. A column matrix has a single column. So it looks something like this. Just one column. And a row matrix has a single row. We are going to start doing some operations with matrices. So today we are going to talk about adding and subtracting with matrices. The only way this works is if you are adding or subtracting matrices of the same size, because what we essentially do is add or subtract the corresponding entries. So the first thing that we'll verify is that they are the same size, and then we will be able to work it out. Just like in general, when you're adding, order doesn't matter, but when you're subtracting, it does. A minus B is going to be different than B minus A. So all of that stays true. Any questions so far? Okay. So let's look at a problem. If I want to find the sum and the difference of these. Okay, so first of all, what's the size of matrix A? And B? So they're both 2 by 4, so we can add them and subtract them. Are they special matrices? Are they square, column, or row matrices? No. So when I do matrix A plus B, I am going to go through and add all my corresponding numbers. So row 1, column 1, we're adding the row 1, column 1. So 2 plus negative 3 is negative 1. 4 plus 4, 8 plus 0, negative 3 plus 1, 0 plus 6, 1 plus 8, 2 plus 2. And negative, or 3 plus 0 is 3. So that is matrix A plus B. So probably, if I hadn't even taught you anything and you just had to guess, that's probably what you would have done. Am I right? Okay. So, A minus B, which would be different than if we did B minus A, we just go through and subtract corresponding numbers. So 2 minus negative 3. 4 minus 4. 8 minus 0. Negative 3 minus 1. 0 minus 6. 1 minus 8. 2 minus 2. And 3 minus 0. What would be different if I said B minus A? Yeah, it would just change the sign of all those numbers. It would be the opposite of them. All right, is that one okay? You guys try this one. So A plus B, what'd you get?
4, negative 5, and then row 2, negative 1, 5, and 4.
Okay. A minus B.
Negative 4, positive 2, negative 5, row 2, 3, negative 1, and 8.
All right, does everybody agree with those? So we can add and subtract matrices. We can also multiply matrices by constants. So we can take a number times a matrix. So I'm giving 3 matrices here. What type of matrix is matrix C, by the way? Square one. All right, and we are going to do these 3 different operations here. So A. We need 4A. That means 4 times matrix A.
ELA 1 needs to report to the gym for EOC testing. Make sure you have your Chromebook and a charger. ELA 1 students report to the gym for testing.
So if you just had to guess, what do you think you would do? Take every number times 4. So 3 times 4, 1 times 4, 5 times 4, negative 2 times 4, 4 times 0, and 4 times 6.
4 times 0 is
Oh, yes it is. Thank you. So the next one, 1/3 C. What do you think that means? Take every number times 1/3. So 9 times 1/3 is 3.
Oh.
Matrix C, yeah.
Oh.
1/3 times 0 is 0. 1/3 times negative 3 is negative 1. And 1/3 times 6 is 2. So what next one? This isn't just a, let's necessarily one-step problem. I want 3a minus 2b. So I'm asking you to do a combination. Now, some people may be able to do it all in one step. They might just be able to work out the answer. Some people might struggle with that. So especially since this is the first one, I'm going to kind of show my work here. And then just know that if you're comfortable, you don't necessarily have to show this much. So 3a would be going through and taking every number in a times 3. So that would give me a 9, 3, 15, negative 6, 0, 18. Minus 2b, so every number in b times 2. 8, 2, 0, 16, 2, negative 6. Now we go through and subtract corresponding numbers. So 9 minus 8 is 1. 3 minus 2, 15 minus 0, negative 6 minus 16, 0 minus 2, and 18 minus negative 6. Is that okay? I'm going to give you guys a problem. So you took a times negative 2, b times 7, and now we are adding corresponding entries. So your first row should be 28, 1, 10. Second row, negative 16, 17, negative 26. Did we get it? All right. Are we pretty good with adding, subtracting, all that? What if I asked you to solve this equation? A capital letter is just representing a matrix. So it's just like any other equation. If you're trying to get G by itself, G is representing a matrix. So we would have to divide by 4. So if I am dividing my entire matrix by 4, it's every single number in there. So matrix G would be what?
2, 3, 16.
What type of matrix is matrix G? A column matrix. Good. What if I asked you to solve this one?
Subtract the matrix.
J is representing a matrix, so to solve for it, I just have to subtract over the entire column matrix with it. Subtract that over. Negative 9 minus 6 is negative 15. 21 minus 10 is 11. 18 minus negative 12, so 18 plus 12 is 30. Right, I'm going to give you guys one. So the first step is you have to subtract over this whole matrix. So 24 minus 5 is it? And okay, and then we divide each one of those numbers by -4. So we get -19 fourths, -5 cos of 6. All right, final problem of the day. You guys think you can do it?
Let's get down.
Alright, so first, to get rid of this matrix, we have to add it to the other side. So if you add all those numbers, you get -7, 12, 4, 12, -8, 6, 2, 8, 8. That's equal to the 1/2 y. To get rid of the 1/2, what do? Yep, you can either divide everything by 1/2, but that's equivalent to just multiplying by 2. You get -14, 24, 8, 24, -16, 12, and 4, 16, 16. Any issues with this? So there is a Math Excel assignment open. Tomorrow we will talk about multiplying the matrices because it's a little bit different. So today, adding, subtracting, multiplying by a constant.